So this section was kind of weird. A lot of people complained about this one, and I forget who I was working with. Maybe Grace yesterday. And we were looking at this, trying to figure out exactly what they wanted for this section. So this one's called Justify Solutions of an Equation with One Variable. And the directions say to determine whether the equation below has one solution, no solutions, or an infinite number of solutions. Afterwards, determine two values of x that support your conclusion. So the equation here is saying that x is equal to x minus 4. So basically what we're saying here is if you think of a number, you need to find a number that when you find that number, it's actually equal to itself minus 4. And I can't think of any possible number for which this would be true, right? Like 10, let's try 10, right? So 10, is 10 equal to 10 minus 4? No, 10 minus 4 is 6. So like, what kind of number could you possibly put in here that would make this true? And the way that we justify this, the way that we show this is we take this and we subtract x on both sides. So if you subtract x on the left, you'd get 0. On the right, you would get negative 4. And so you have to ask yourself, when would 0 equal negative 4? And the answer is never. So we would say something like this has no solutions. And what they want you to do here is they want you to put in a value of x that makes this equation false. Remember, an equation is just a statement about two quantities, right? So basically what we're saying here is if we go, let's let x be 10. So a value of x that makes this equation false is 10, which when substituted into the equation and simplified, so I'm going to actually plug in 10 for x. Anywhere where I see an x, I'm going to put a 10, okay? 10 is equal to, then I'm going to put a 10 here, 10 minus 4. What would I get on the right side of the equation? Right, there's the left side here, and then there's the right side here. What would I get on the right side? I would get 6, right? 10 minus 4 is 6. So obviously, if I get a conclusion here, an equation that makes no sense, like that 10 is equal to 6, then that's false, which means that the number that I tried to plug in for x doesn't actually work. It doesn't make it true, and it's not a solution. Okay, another value of x, let's do another one. How about 8? So if we throw in 8, what would we get? We would get 8 for x is equal to 8 minus 4, which is 4. And that's basically what they want you to do on this. So we'll look at a few more. How about this one? So if you want to solve for x, you're going to divide by negative 3 on both sides. When you do that, you get that x is equal to negative 15 divided by negative 3, which is 5. So that's one solution. Basically, what we're saying is the only number in the world that would actually make this true is if x is, if you replace the x here with a negative 5. So we're basically saying negative 3 times negative 5, sorry, not negative 5, positive 5. Positive 5, negative 3 times positive 5 would give us negative 15. So a value of x that makes the equation true, in fact, the only value that makes it true is 5, which when substituted into the equation and simplified makes the equation turn into, so if we actually throw a 5 in here, what would we get? We would get negative 3 times 5, which is negative 15. And on the right, you get negative 15. Okay. If you get an equation that's true in the end, that means that whatever number you plugged in for x must make it work and make it true, which means that you have a solution. 5 is a solution. How about a number for x that makes the equation false? Well, 5 is the only number in the world that makes it true, so you can try any other number and it'll be false. So if we throw a 6 in where x is, what would we get? Negative 3 times 6 would be negative 18. And then on the right, we just have negative 15. Obviously, negative 18 does not equal negative 15. Same thing here. If we divide by 2, we would get x is equal to 5. So when we say x is 5, we get 2 times 5 is 10, and that's obviously equal to 10. And a value for x that makes this false, how about 3? So 2 times, if I plug in 3 where the x is, 2 times 3 is 6. Is that actually equal to 10? No, it's not. Okay, how about this? So x plus x plus x plus x is equal to 4x. Let's just try a number. How about 10, right? So 10 plus 10 plus 10 plus 10. That would be 40 over here. The question is that actually equal to 4 times 10? 4 times 10 is 40. So yeah, that's actually true. So 10 is a solution here. But before we just go saying, hey, there's one solution, let's think about this. How about, let's try another number. How about 5? So 5 plus 5 plus 5 plus 5. That would give you 20 over here. And on the right, 4 times 5, x is 5, would give you 20. So 5 also works. So what you'll notice here is that on the left, you literally have, if you just add these up, you have 4x, right? And what is on the right? 4x. When would 4x equal 4x? Or when would 4 times a number equal 4 times the same number? Always, right? Like it doesn't matter what number you plug in. If you add that number 4 times, you're going to get 4 times that number. So basically what you could do if you were solving this is you could add all these up and you'd say 4x is equal to 4x. And then you might subtract 4x from both sides and you would get 0 is equal to 0, which is always true. So in scenarios like this, these are infinite solutions. So a value for x that makes this true is you can plug in anything you want, right? So we tried 10, and when we simplified it, we got 40 was equal to 40, right? We added 10 4 times, and then we did 4 times 10 over here, and they're equal. How about 5 for x? So 5 plus 5 plus 5 plus 5, that's 20. 4 times 5 on the right, that is also 20. We get a solution there. Okay, so that's how you're going to work through problems of that type.